Hi everyone. Today we're going to be talking about the idea of going from standard form to factored form. So last week we were talking about the idea if you had factored form, how could you convert it into standard form and then graph it? Okay, so go ahead and follow along with your notes. You can convert standard form to factored form using multiple methods. So again, you could use algebra tiles like we did in the activity today, or you could use something called the reverse box method, which is kind of like what we did last week. If you have the box and then you actually try to find the numbers on the outside, okay? And then what we're going to be talking about today is something called the diamond method, and a bunch of different ways and more, okay? So in standard form, it is essential to remember that B, because remember it looks like this. I'm saying that B is a sum of like terms. That means you add to get it. Okay? And C, that's this last one, is a product of like terms. So a product is when you multiply. So let's check out to see what I mean by that practically. So what we learned last week is that you could multiply x plus 3 and x plus 2, and if you want to use the box method, you could do it like this. X plus 3, x plus 2, you end up with x squared plus 3x plus 2x plus 6, okay? Now what you'll notice here is that you have two like terms, 3x and 2x. So 3x and 2x, when you add them, you get 5. So that's what I'm saying is that this 3 and this 2, if you add them, you get 5. But if you multiply 3 and 2, you get 6, and that's the last one. So what I'm saying here is that B is going to be the addition of this term and this term, and that C is going to be multiplying 3 and 2. Okay, let's look at what that looks like practically. So here's the first example. What we want to do here is we want to write it into factored form. So the way that I'm going to teach you to do that today is using something called the diamond method. So to do that, we need to be able to label A, B, and C. Now if you look at A, there actually isn't a number in front of x squared, so that means that implied in front of there's 1x squared. So A is equal to 1. B is equal to the number in front of x, which is positive 4. And then C is the last one, positive 3. Okay? So now how you're going to set up this diamond method is you're going to kind of create this x. Okay? In the top you're going to write A times C. So A times C in this case is 1 times 3, which gives you 3. And then in the bottom you're going to write just B, which is 4 in this case. Alright? Now like we talked about on the last slide, what you want to do here is you want to find two numbers that add or sum to 4, and two numbers, the same numbers, that will multiply or give you a product of 3. So the way that I'm going to think about this is I'm going to take the number 3, I'm going to think about numbers that can multiply to get to 3. The only ones that I can think of that are whole numbers are 1 times 3. So what I want to check here is if these two numbers will add to 4. So 1 plus 3, does that give me 4? Yep, that checks out. And then 1 times 3, does that give me 3? Yeah, that checks out. So these are the two factors that I want to use. So all I'm going to do here is I'm going to write f of x is equal to x plus 1 and this positive 1 is just coming in from here, and then x plus 3, which is just coming in from here. So now, this is convenient because now I have my equation in factored form. Now that I know it's in factored form, I can do everything that I've been doing since the beginning of this unit using x-intercepts. So I'm going to take each factor, set it equal to 0. X plus 1 equals 0, and x plus 3 equals 0. I solve these out using inverse operations. I get x equals negative 1 from this one. And from this one, I get x equals negative 3. So I've got negative 1 comma 0 and negative 3 comma 0. I can plot these right here, and I can move forward. For my y-intercept, I'm actually going to show you something a little bit different today. I'm actually going to use the standard form equation. So remember what I do is I substitute x equals 0. So I'm going to write f of 0 equals 0 squared plus 4 parentheses 0 plus 3. All I did was replace the x's with zeros. Now what's convenient about this is that you're going to see a lot of this cancels out. 0 squared, that's just 0. 4 times 0, that's just 0. So you're just left with a positive 3. Meaning that your y-intercept is positive 3. I'm going to go ahead and plot that. That's right here. Okay, now for my vertex, I need to figure out my halfway point, so I'm actually going to figure out my axis of symmetry first. I find the halfway point between the two roots, which is going to be x equals negative 2. I'm going to substitute that back in to the equation to figure it out. So again, I'm going to use the standard form equation, so maybe I'm going to put negative 2's for each of these x's. So I'm going to write f of negative 2 equals negative 2 to the second power plus 4 parentheses negative 2 plus 3. Negative 2 to the second power makes a positive 4. Positive 4 multiplied by negative 2 makes negative 8 plus 3. Just brought that down. 4 minus 8 makes negative 4 plus 3 makes negative 1. So f of negative 2 is equal to negative 1. So I go to the left 2 spaces, down 1 space, and I just found my vertex right here. So I've got this point, and this point, and this y-intercept that are all in my parabola. So I know that it's going to look something like this right here. Okay? Let's move on to the second example. Okay, so for the second example, again, I'm going to label A, B, and C. In this case, A is equal to 1, remember, because there's nothing in front of it. B is equal to negative 6. Notice how I include the sign before it. And then C is equal to positive 5. So now what I'm going to go ahead and do is draw my diamond, or my X. I'm going to put A times C in the top. I'm going to put B in the bottom. So A times C, 1 times 5 gives me 5. B is negative 6. Alright? And again, from our first slide, what I know here is that I want to find two numbers that multiply to 5, have a product of 5, and will add or sum to negative 6. Now if you're thinking about this, if you want to get to a negative number when you're adding, then you know that at least one of these numbers is going to have to be negative. But we'll get to that in a second. So I'm going to try and figure out what numbers multiply to 5. I only know two numbers that will multiply to 5 that are whole numbers. So that's 1 and 5. All right. So now let me check something. 1 times 5, does that give me positive 5? That checks out. 1 plus 5, that gives me a positive 6, so that actually doesn't work out. But I know what I could do So I actually could put a negative here and a negative here, and let's see how that changes. -1 plus -5, that does give me a -6, so that does check out. Then -1 multiplied by -5, negative times a negative, also gives me a positive. So -1 and -5 are actually the correct factors here. So what I'm going to do is I'm going to write y equals, set up my factors, and in this case it'll be x minus 1 and x minus 5. Again, convenient, I have it in factored form so I can go ahead and do all this work on the side to figure out my graph quickly. X minus 1 equals 0, x minus 5 equals 0, I add 1, so x equals positive 1. That's one of my x-intercepts, 1 comma 0. Then I'll add 5 here, add 5. So x is equal to positive 5, and that's my other x-intercept. So 1 comma 0 and 5, 0. And that is going to be right here and right here. So those are my x-intercepts. To find my y-intercept, again here, I'm going to use my standard form equation. And hopefully you'll start to realize that really, if you're in standard form, just like in slope-intercept form for lines, these terms become zeros, and all I'm left with is the last number. So that one is just like lines, where the last number is just the y-intercept. So 0, 5, that's up here. For my axis of symmetry, I want to find the halfway point, so 1, 2, 3, 4 spaces. So that means that halfway of that is going to be 2 spaces, right at x equals 3. 2 spaces from this way, 2 spaces from this way, gives me x equals 3. And that's the x value of my vertex, so I just need to substitute in my vertex, and then I will know where it is. So I'm going to write y equals 3 squared minus 6 parentheses 3 plus 5. So again, all I did was I substituted 3's in for the x's. 3 squared gives me 9. Negative 6 multiplied by 3 gives me negative 18 plus 5. 9 minus 18 gives me negative 5 plus 5. Negative 9 plus 5. And that gives me a negative 4. Let's see if that makes sense. 3 comma negative 4. That's to the right 3 spaces and down 4 spaces. So this is my vertex. Let's see if that actually makes the shape of a parabola. So if I plot all of these points, that makes the shape of the parabola. Okay, and here's the last example. Again, we're first going to convert it into factored form so that we can be able to figure out x-intercepts, y-intercept, vertex, axis of symmetry, and so on. So I've got A, B, and C. A is 1, B is 2, C is negative 3. So A is 1, B is 2, and C is negative 3. Notice how I keep the sign, positive 2, positive 1. Okay? Create my X or my diamond. A times C, that's going to be a negative 3. And B is going to be a positive 2. So I want to find numbers that multiply to negative 3. Now, if I want to multiply to a negative, that means that only one of my numbers needs to be negative. So I can either be negative 1 and positive 3, or positive 1 and negative 3. Okay? So if I know that I need to add to positive 2, that means that my bigger number needs to be positive. So out of these two, my bigger number is 3, and here it's negative, so the case that I want right here is negative 1 and positive 3. Let me double check that. Negative 1 plus 3 does make positive 2, and negative 1 multiplied by positive 3 does make negative 3. Remember, I want to multiply to this top number. So I just figured out my two numbers that are going to be in factored form. So in this case, I'm going to set up my factors, and it's going to be x, in this case minus 1, because this was a negative 1, and then x plus 3, because this was a positive 3. This is my factored form of my equation, so now I can use it to find x-intercepts, y-intercept, vertex, axis of symmetry. Okay, so x minus 1 equals 0, and x plus 3 equals 0. Add 1, so x is equal to positive 1, that's one of my x-intercepts. And here I'm going to subtract 3, so x is equal to negative 3, that's my other x-intercept. So here's positive 1, and actually this graph is not going to work out for us, so we want to make sure that we go over to negative 3. I'm actually going to move this graph over slightly. So this is positive 1, negative 3, here's negative 2, here's negative 3 over here. This is negative 3. And here's positive 1. Okay, so I've got my x-intercepts. Okay, so to figure out my y-intercept, I want to substitute in x is equal to 0. Now remember, if my equation is this, I'm going to realize that my y-intercept is just the last number. So in standard form, the last number will be your y-intercept. So h of 0 equals negative 3, meaning my y-intercept is at 0, negative 3. So I'll plot that. For my vertex, I need to find my axis of symmetry, meaning I need to find my halfway point. So halfway between negative 3 and positive 1, so I've got negative 2, negative 1, 0, and 1. So that's 4 spaces, meaning that my axis of symmetry is going to be halfway at x equals negative 1. I'm going to substitute that into my equation. Remember, it's the x value of my vertex. So I'm going to say h of negative 1 equals negative 1 to the second power plus 2 multiplied by negative 1 minus 3. Negative 1 times negative 1 gives me a positive 1. Remember, that's what negative 1 to the second power means. 2 times negative 1 gives me minus 2. So 1 minus 2, and then I just bring down my minus 3. 1 minus 2 is negative 1. Minus 3 gives me negative 4. So h of negative 1 is equal to negative 4, meaning my vertex is negative 1, to the left 1, and down 4 spaces, meaning that this is my vertex right here. So here's a point at negative 3, here's a point, here's a point, and here's a point. And if I was to draw my parabola, it would look something like this. Okay, and that's the video for the day.